Hello class, so we're continuing on in section 3 and we're going to continue our introduction to functions, and today we're going to determine if an equation represents a function. So yesterday we examined if a relation is a function both numerically and graphically, and we examined and took a look at that. And so today we're going to examine and see if a function is going to be, or if a relation is a function based upon an equation. So determine if the equation represents a function. So to do this, the easiest process is we want to solve for y, and so we want to get y by itself. And so here's my y, I want to get that by itself. So to do that, I'll subtract x cubed on both sides, and so I get y squared equals 1 minus x cubed. And then to get rid of that square, I have to take the square root of both sides, and so I'm going to get y equals plus or minus the square root of 1 minus x cubed. So now that we have this, let's kind of examine what this implies. So let's just say hypothetically, if I plug in x equals -1. Now if I plug in x equals -1, this is going to simplify into plus or minus the square root of 1 minus -1, because -1 cubed is -1. And so that's going to give me plus or minus the square root of 2. So that means that this -1 is going to map to positive root 2 and negative root 2. So since my x value, -1, maps to two different y values, positive root 2 and negative root 2, this is not a function. And so a pattern that will develop, and we're going to see, is that if we ever see this notation of plus or minus, we're going to know that it does not represent a function. So on this next one, so let me conclude, not a function. So now let's take a look at this next one. This one's going to require a little bit of fancy algebra, and so I want to get all my y's on the same side, and so I'm going to get x squared y minus y equals, and then 3 plus x, because those cancel out. So all I'm trying to do right now is I'm just getting that y by itself. So now I can factor out that y. And so factoring out that y, I'm going to be left with x squared minus 1 equals 3 plus x. And then now, to get y by itself, I'm going to divide both sides by x squared minus 1. And so then I'm going to get y equals 3 plus x over x squared minus 1. And so in this case here, the question then becomes, do I see that plus or minus? In this case, no. And so because I don't have that plus or minus, this equation does represent a function. So yes, it is a function. Now, generally speaking, the pattern that we're going to be seeing here is the first thing we're going to have to do is we have to get y by itself. So notice in this equation, I got y by itself. In this equation, I got y by itself. Once you get y by itself, you have to examine, do I have a plus or minus? If you do have a plus or minus, you know that it's then not going to be a function. So because there's a plus or minus, not a function. No plus or minus, yes, it is a function. Now, generally speaking, these plus or minuses come when you take an even root, and then the other time you get a plus or minus is when you have the absolute value around a y. And then you're going to get a plus or minus that's going to affect the outcome of what our variable is going to be, or what our function is going to be. Let's take a look at this next one. So determine if this equation represents a function. And so for this one, let's get all of our y's to one side. So I can add 3y to both sides. So I'm going to get y squared y plus 3y equals 1. Right? I'm just trying to get y by itself, so I can factor out a y that's in common, so I get x squared plus 3 equals 1, and then I can divide everything by x squared plus 3. And so I'm going to get y equals 1 over x squared plus 3. So I don't see an a plus or minus, and so therefore I can make the assumption, yes, it's a function. Looking at this next example here, trying to get y by itself, so subtracting x squared on both sides. So I get y cubed equals 1 minus x squared. And then to get y by itself here, I want to take the cube root to both sides. And so taking the cube root to both sides, I get y equals the cube root of 1 minus x squared. Now in examining this, we might be thinking to ourselves, oh, okay, well I took a root, therefore there must be a plus or minus. Remember, you only get a plus or minus when you take an even root. Since this number was odd, it's not an even root, therefore there's no plus or minus. So because I don't see a plus or minus, this is a function. This next one here, I got to get y by itself, so I can subtract x squared on both sides. So I get negative y squared equals 1 minus x squared. Then I can divide everything by that negative 1. And so I get y squared equals negative is a positive, so I can say x squared and then positive negative is a negative, so it'll be x squared minus 1. I know I just switched the order, that's okay. It doesn't matter. If you guys in your analysis didn't do that, that's fine. Now getting y by itself, I take the square root to both sides. So now that I took an even root, right, that's even. Because I took an even root to both sides, I'm going to have y equals plus or minus the square root of x squared minus 1. Because of that plus or minus, it's not a function. And this last one, kind of like the same idea here. I can subtract x, y on both sides. Now the reason why I did that is I want to get all my y's on the same side. And so x squared y minus xy equals 1. Now what's in common is a y, so I can factor out that y. And so I'm going to get x squared minus x. And then divide both sides by x squared minus x. And so I get y equals 1 over x squared minus x. There is no plus or minus, so therefore it is a function. And that would be my answer. So remember, get y by itself. Once it's by itself, determine if there's a plus or minus. So in closing, what did we learn today? Well, we took a look at how to determine if an equation represents a function. Now I just need you guys to help remind me a little bit, what is a function again? Right? We learned that the other day, and just kind of I need a little refresher there. And how do I find the domain from a graph? Like, what does that represent and mean? And what is the key characteristic of an equation that does not represent a function? This does conclude our lesson. If you have any other questions, please leave them in the comments.